Hello students, today we'll discuss AS paper, Cambridge Physics. My name is Nariman Mealim. I'm located in Baku. My mobile and email are shown here. So this is the cover page, paper 1 multiple choice, May 2018 for 1 hour 15 minutes, Cambridge AS paper. You should use calculator. And here you have some constants and some formulas at the beginning. These formulas are for both AS and A2. Let's start. Question 1. A sheet of gold leaf has a thickness of, a gold atom has a radius of, approximately how many layers of atoms are there in the sheet? So here they just check that you know what is micro, what is pico, and how to use them. So total thickness is 0.125 micrometers. So we substitute micro with 10⁻⁶, diameter 2r, they give us radius, attention. So 2 times 174 instead of pi, we put 10⁻12. We divide total thickness by each diameter and we get number of atoms. So number of atoms is 359, so the closest answer is C. Question 2. The drag coefficient CD is a number with no units. It is used to compare the drag on different cars at different speeds. CD is given by the equation. So it has no unit, where F is the drag force, ρ is density, A is cross-sectional area, and car and V is speed. What is the value of N? So as CD has no unit, F has the same unit as this expression. So let's find derived unit in base unit, in terms of base units. So F equals MA, M kilogram, A meter per second squared. Vn rho A, so V is speed meter per second raised to nth power, then kilogram per meter cube meter squared. Then we open this bracket, raised to n, and then we balance. So this should be equal to this. From this we get n equals 2 and n equals 2. So no contradiction. We choose answer B. Question 3. A student measures the current through a resistor and the potential difference across it. There is a 4% uncertainty in the current reading and 1% uncertainty in the potential difference reading. The student calculates the resistance of the resistor. What is percentage uncertainty in the calculated resistance? As formula is for resistance is voltage divided by current, so we have two quantities divided or multiplied. Then we should find the fractional uncertainty or percentage uncertainty will be the sum of uncertainty of each of the quantities that you multiply or divide. It doesn't matter, you divide or multiply, you just add the uncertainty. So we add 4, 1, we get 5, and we choose answer G. Question 4. A student applies a potential difference across a resistor for time. The student calculates the energy using the equation below. What is the absolute uncertainty in the calculated energy value? So here we have V squared time, and resistance. So for each quantity we find percentage uncertainty. For v squared it will be 2 times uncertainty for v. So we have percentage uncertainty in energy equals 2 times percentage uncertainty in v plus r and t. So we add this uncertainty, so we get 0.10. So percentage uncertainty is actually fractional uncertainty is 0.10. Then moving e to the right, we get absolute uncertainty. It will be 8 joule. Answer is D. Question 5. The velocity of an object changes with time as shown. Which graph best shows the variation with t of displacement s of the object? So first object moves, velocity is positive, so it moves up, then it moves down. So first we have increase of uncertainty of displacement and then decrease. Let's check. So we have increase and decrease in A and D, but here we have constant acceleration. For constant acceleration we have the following formula, and this formula is parabola that opens down, so we should choose A. So we choose A. Question 6. A projectile is launched at an angle to horizontal at time t0. It travels over horizontal ground as shown. Assumes that resistance is negligible. Which graph best shows the variation with time of the speed of the projectile from when it is launched to when it lands to the... So speed consists of two components, horizontal and vertical. Horizontal doesn't change. Vertical first increases and then decreases. So we should decrease this because it goes up. So first speed should decrease, not to 0 but to value equal to horizontal component, and then increase. So decrease, increase, decrease, increase. We have B and D and C, but not to 0. We have only in C, so we choose answer C. We choose answer C because decrease, not to 0 at the top, and then increase. Question 7. A skydiver falls vertically from a helicopter and reaches constant velocity. The graph shows the variation with time of speed of the skydiver. Which graph shows the variation with time of the distance fallen by the skydiver? So skydiver first move almost at constant acceleration and then at constant speed. So for constant acceleration, question 7. For constant acceleration we have parabola, and for constant speed we have straight line. So where we have parabola, clear parabola we have here, and straight line we have here. And this parabola is upward, so we choose C. Question 8. A tennis ball of mass 55 grams is traveling horizontal with speed 30 meters per second. The ball makes contact with the wall before rebounding to horizontal direction with speed of 20. The ball is in contact with the wall for time. What is the average force exerted on the wall by the ball? So mass we turn into kilogram, speed is 30, initial speed is 30 meters per second, velocity. Final velocity is in opposite direction, minus 26 meters per second. We use new formula in AS for force, it is rate of change of momentum. Change of momentum is mv minus mu, so we put the values. We take into account that final is minus 20, minus 30, which is minus 50. So velocity and momentum are vectors, so we care about direction. And which answer? Choose answer D. An elastic collision occurs between two bodies, x and y. The mass of body x is m and the mass of body y is 4m. Body x travels at speed v before the collision and speed 3v5 in the opposite direction after the collision. Body y is stationary before its collision. So here we have picture, clear picture. What is kinetic energy of body y after the collision? Question 9. So kinetic energy is half mass times velocity squared. So for I called it x, unfortunately. So I called unknown velocity x. So mass is 4m. Momentum equals mass times velocity. The conservation of total momentum. Momentum before is mv. Momentum after collision is m times minus, because in opposite direction, minus 3v5 plus 4m, and unknown speed is x. We equate these values. We get unknown speed is 2/5 of v. We put this 2/5 of v into kinetic energy and we get 825. We don't have such answer here, so we choose this one, because if we simplify it will be 8/25. So answer C. The density of water is 1 and density of glycerin is 1.3. When water is added to a mixture of measuring cylinder containing 40 cubic centimeters of glycerin, so that the density of the mixture is 1.1. Assumes that the mixing process doesn't change the total volume of the liquid. What is the volume of water added? Purely a mathematical question, but what you should demonstrate here, understand the idea of density. Density of any object is mass divided by volume. If we add x centimeter cube of water, then our density will be 1.1. Mass is mass 1 plus mass 2 and volume 1 plus volume 2. So mass we find by density multiplied by volume. For glycerin it is 40 cubic centimeter and for water it is unknown x. Then we solve equation with one unknown, linear equation, and we get 80. So I80 is D. An astronaut throws a stone horizontally near the surface of the moon where there is no atmosphere. Which row describes the horizontal and vertical forces acting on the stone after release? Question 11. In horizontal direction, as they say, there is no air resistance, so no force. In vertical, constant gravitational pull, which is called weight, and which equals mass times g. And mass is constant, g is constant, so this force is also constant. We choose answer C, so horizontal force 0 and vertical force constant. A cylindrical block of wood has cross-sectional area A and weight W. It is totally immersed in water with its axis vertical. The block experiences pressure P12, PT and PB at its top and bottom surfaces respectively. Which expression is equal to the upthrust on the rock? So upthrust is resultant force between two forces. One force pushing up from the bottom and another force pushing down from the top. So the force pushing up will be P bottom by A, force pushing down will be P top by A. And we have this expression, so we choose answer B. A uniform diving board is held by two fixed rods at points P and Q. A person stands at end R of the diving board as shown. The forces exerted by the rods on the board are vertical. The board remains in equilibrium. That's important, equilibrium. As the person slowly moves toward point Q. So, person moves forward. It means that the force produces less and less turning moment, and pivot is at this point. So if we have less clockwise moment, then we have less anti-clockwise moment, so this force also decreases. Which row? Okay, so question is about forces and P and Q. What happens to them? So as I said, the force at P decreases because it should produce less, less anti-clockwise moment. As weight and this force act in one direction, so one of the force decreases, it means that reactions should also decrease. So we choose decrease, decrease. Decrease, decrease is A. So we choose answer A. Two forces, each of magnitude F, act in opposite direction on a rod. Each force acts on the rod at distance d from the pivot. What is the torque of this couple? About P. So torque is one of the forces multiplied by perpendicular distance between these forces, F to D. So we choose answer 2FD, answer C. The vector diagram shows three coplanar forces acting on an object at P. The magnitude of the resultant of this force is 1 Newton. What is the direction of this resultant force? So, first of all, the magnitude is not 0. So we are going to use polygon rule. So we will draw one force after another, and the resultant will be from the start to the end. So force 4 Newton we keep as it is, 3 Newton we draw, and 4 Newton is 3 squares to the left and 2 squares and a bit down. 3 squares to the left and 2 and a bit squares down. So which direction it should be? I think that's the best direction. The fact that it is 1 Newton we didn't use. In normal driving condition, electrical car has a range of 150 kilometers. This uses all of its 200 megajoule of energy stored in its batteries. With the batteries initially fully charged, the car is driven 100 kilometers in normal driving condition. The batteries are then recharged for a household electrical supply, delivering at a constant rate of 13 amperes and potential difference of 230 volts. What is the minimum time required to recharge the battery? So after using the battery for 100 kilometers, it lost some energy. So used energy will be fraction of energy, of the total energy. Fraction is 100 kilometers by 150, and this energy we should So we should provide the same energy, and electrical energy is IVT, so T equals E over IV. So we put this energy and divide by current and by voltage. We get seconds, we divide by 3600, we get hours. So here we get 12.4, so answer is B. The diagram shows a ball of weight W hanging in equilibrium from a string. The string is in the angle theta to the vertical. The tension in the string is T. The ball is held away from the wall by horizontal force P from a metal rod. What is the relationship between the magnitude of T, P, and W? So this is a picture. I add these forces and I am getting a closed triangle because forces are balanced. The angle between P and W is 90 degrees, so we have Pythagorean triangle and we use Pythagorean theorem. So T squared will be P, T squared will be P squared plus W squared, and we have such choice here, it is C. Question 18. A steel sphere is dropped vertical onto a horizontal plate. The sphere hits the plate with speed u, leaves it at speed v, and rebounds vertical to half of its original height. Ignore a resistance. Which expression gives the value of v over u? So we have conservation of energy. Energy before equals energy after. So before strike, potential energy changes into kinetic. So mgh equals half mu squared. After bounce, kinetic energy changes into potential. So mg half h equals half mv squared. So we divide these two equations one to another, and we get this expression. We square root both sides. We get this expression. We find reciprocal, and answer is C. Next question is 19. A car of mass 500 kg is at rest at point X on the slope as shown. The car's brakes are released and the car rolls down the slope with its engine switched off. At point Y, the car has moved through a vertical height of 30 meters and has a speed of 11 meters. What is the energy dissipated by frictional force between the car moves from X to Y? So at X we have potential energies, at Y we have kinetic energy plus heat produced by frictional forces. So we put here given information. Either we use work energy theorem, which tells us that change of total energy equals minus work done by friction, or conservation of energy, potential energy before equals kinetic energy after plus heat. So heat will be change of potential energy minus kinetic energy. So change of potential energy is mgh, change of kinetic energy half mv squared. So we put the value and we get value with two significant b figures. An elastic material with Young modulus E is subject to a tensile stress S. Hooke's law is obeyed. What is the expression for elastic energy stored per unit volume of the material? So first of all, you should remember this graph, and from this graph we understand that energy stored and work done is half F delta L. Then we know that volume is area multiplied by length. So a formula for Young modulus is this one. So it is tensile stress by tensile strain, force over area divided by delta L over delta L over L. We rearrange it for F. We have an expression for F. Why for F? Because we should get rid of this F. So energy divided by volume equals our expression for F divided by volume. We put the volume is AL, then we simplify, we combine delta L, and we get expression in terms of strain squared. Then we write expression for strain expressed in terms of stress. We substitute stress for strain, rearrange, and we get D. Next question. The graph shows the length of spring as it's stretched by an increasing load. What is the spring constant of the spring? Spring constant will be extension divided by force. Extension is difference between 15 and 10. So under force 0.4 it was extended by 5 centimeters. Centimeters should be changed into meters because answers are given in meters. So this is the Hooke's law. Spring constant is F over delta L, delta X. Delta X will be change of X. So we divide force by change of X and we get answer D. Two lasers emit light in a vacuum. One laser emits red light and the other emits green light. Which property of the two lasers must be different? Amplitude, no. Frequency, yes. Intensity, no. Speed, no. So answer is B. Question 23. The diagram shows a screen of cathode ray oscilloscope displaying as way. The time base of the CRO is set at 10 milliseconds per division. What is the frequency of the wave? To find frequency we need period. Period is distance between positions of this so picture is repeated after time period, which is called period. Here it is 1, 2, 3, 4 and about 2 divisions. So period is 4.2 divisions. Each division is 10 milliseconds. So we get 42 milliseconds. Milliseconds we change into second by replacing milli with 10 minus 3. Then we use formula frequency is 1 over period. And we get answer 24, which is D. Question 24. A string is fixed at one end and the other end is attached to a vibrator. The frequency of the vibrator is slowly increased from 0. A series of stationary waves is formed. Assume that for stationary waves there is node at P. So node is here and node is at P. What are the first 5 wavelengths of the stationary waves that could be formed? And here we have choices. So first frequency is node. So between two nodes we have lambda over 2 and lambda over 2 equals the length of the string. So L equals 2 lambda. Then we have node in between. So node and node is lambda over 2 and it equals half of the length. Or lambda over 2 and lambda over 2 equals length. So equals, and we already have the answer. So this is the answer. L and no, not this. This is the answer. 2 lambda and 2L and then L. So answer A. No need to check other frequencies. 25. Which region of the electromagnetic spectrum has waves of wavelengths 1000 times smaller than the wavelength of visible light? So first of all, infrared is longer, microwave is longer, ultraviolet is too close, X-rays is far, so we choose D. 1000 can be X-rays, but at the same time you should memorize the wavelengths, typical wavelengths for all electromagnetic spectrum. That is must for AS students. The diagram shows apparatus for measuring the frequency of a sound wave. Sound of the unknown frequency is reflected back from a metal plate. A microphone placed at a distance d from the metal plate detects the sound intensity. Minimum intensity is detected with d equals so much. The plate is moved further away from the microphone until the next minimum is detected. So minimum is detected means that we have here note. The next minimum, another note. So we actually know the distance between two notes. So standing waves is 4, minimum distance between two notes is 3 centimeters. So corresponds to lambda over 2. So lambda equals 2 times 3, 6 centimeters. From wave equation we have formula for frequency. Frequency is speed divided by wavelength. So we get answer C, which is 5600 Hertz. 27. An astronomer observes the light from a star that is moving away from the Earth. For the observed light that has been increased due to the star motion, what has been increased due to the star's motion? So when object is moving away, the wavelength increases and it is called the redshift, so we choose answer D. Very simple question. Right, the diagram shows a stationary wave at the time t0 that has been set up on a string fixed between points P and S. So we have standing wave. The notes of the stationary waves occur on the string at P, Q, R, and S. Point X is moving down at time 0. The point on the string vibrates with the same period and maximum amplitude 2 cm. The displacement S is in the upward direction. Is positive in the upward direction. Which graph best shows the variation with time of the displacement S of point Y on the string? So from time 0, so we will get picture here. Here we'll get antiphase and here we'll get in phase. So Y and X will be using in phase, but because Y is in the middle, it has maximum amplitude 2 centimeters. Y is not in the middle, so it will have less amplitude. So we choose where we have positive part moving, no negative moving down and with amplitude less than 2 centimeters. So we choose answer A. Right, next question. A two-source interference experiment uses the apparatus shown. What is the main purpose of the single slit? So a lamp gives us not coherent light but bursts of light. To have coherent light coming through two slits, we need single slit. So it will have diffraction, and as if one light is going emerging out of double slit. So to provide coherent light, so answer C. Two large parallel metal plates X and Y are situated in vacuum as shown. Plates X and Y carry equal and opposite charge. What happens to the force on the positive charge particle as it moves from plate X to plate Y? So if charge is moved, positive charge is moving, it is moving in uniform electrical field, and force will be charge times constant, uniform magnet. So we choose answer D. It remains constant because the positively charged particle is in uniform electrical field. Standard picture of electrical field. 4 diagrams represent the electric field between two oppositively charged point charges are shown. Which diagram correctly shows the electric field? So I think it is diagram. So because it should show the force on positive charge, so outward for plus, inward for minus. Here mistake, it should be inward. Here should be outward, here mistake, and here outward. So we choose answer A. Question 32. The power output of electrical supply is potential differences. The two wires between the supply and the kettle each have a resistance as shown. What is the power supply to the kettle and what is the potential difference across the kettle? So we have we know voltage and we can find current because power equals current times voltage, so we can find current. So current flowing through this circuit, it will be power divided by voltage. So current we know. Part of the voltage falls on this resistor and this resistor. To find how much falls, we calculate current by both resistors, and it appears to be 10 volts. So 10 volts out of 240 falls here. It means that on the kettle we have 240 volts. As we know the voltage and also current flowing, because in series connection we multiply current by voltage, we get power in the kettle, and all this gives us answer in A. (33) Which graph shows the variation of voltage with current for a semiconductor diode? So when voltage is positive, current is positive and it increases dramatically at some voltage. So this is the graph that I need. Here voltage increases dramatically. Here voltage increase dramatically. Here voltage. So they just put the axis, rotated them, and answer is B. So answer 33, answer is B. Straightforward. 34. Four different resistors are arranged as shown. A current 1.5 enters the network and leaves through junction Y. What is the current in the resistor 30 ohm? So we have current splits into two currents. One current goes through 30 ohm, another current goes through this part. So let's look. First of all, let's find the resistance of this part. So here we have 1, 2, 3 resistors connected in series, so we get 140 ohm. Now we know that voltage across 70 ohm and our R resistors are equal. So let's calculate, let's call current through 70 ohm X, current through resistor R Y. So we get 70 times X equals 140 times Y, or X equals 2Y. On the other side, if we add this current, we get 1.5. Solving this equation, we get Y equals 0.50, and this 0.50 flows through all these resistors and even 30 ohms. So we get answer B. 35. A cell of constant EMF drives the current I through external resistor R. The terminal potential difference across the cell is V. When the internal resistor R of the cell increases, what is the effect on V and I? So actually V is potential difference across resistor R. So when resistance R increases, current through the circuit decreases, and as a result, less voltage falls on R and less voltage is shared. So voltage on R decreases because we have potential divider R, small r, big R. If small r increases, big R is getting less voltage. So we get decrease, decrease. It is choice A. Question 36. Let's look. In the circuit shown, the batteries are identical and all have negligible internal resistance. All of resistors have the same resistance. Diodes have zero resistance when conducting and infinite resistance when not conducting. In which circuit is the current in the battery greatest? So actually battery here work as a switch. So here switch is on, so we have two parallel resistors. Here switches are on, but we have resistors in series. Here we have, this is off, so we have only one resistance, and here we have, this is blocked. Again we have one resistor. So only here we have the smallest resistance because two resistors in parallel, so current will be the greatest. 37. A thermistor is an electric component with a resistance that varies with temperature. A thermistor is used in a fire alarm system. The alarm is triggered when the potential difference between X and Y is 4.4. What is the resistance of T when the alarm is triggered? So we have 12 volt EMF. Here we'll have 4.5 volt. The rest falls here. So first we will find how much voltage falls here. We'll find how much current flows here. And then current multiplied by unknown resistors will give us 4.4 volt. So first resistance, for resistor we find the current, for thermistor we find 4.5 falls here, so here we directly find the current. Then we find voltage here by 12 minus 4.5, and current we know, voltage we know, we divide voltage by current, we get resistance. Yeah, because of confusion, so we know here we have 4.5 volts, so we divide it by resistance, we find current. Then here voltage will be 12 minus 4.5 divided by our current. 38. In the alpha particle scattering experiment, if beam of alpha particle is aimed at a thin gold foil. Most of the alpha particles go through or are deflected by a small angle. A very small proportion are deflected through more than 90 degrees, effectively rebounding downwards the source of the alpha particles. Which conclusion about the structure of atom cannot be drawn from this experiment alone? So, most of atoms is empty, yes. Most of mass of atom is concentrated in the nucleus, yes. The nucleus contains protons and neutrons. Why? We have no idea about neutrons. Nucleus is charged, so C. 39. How many neutrons does each nuclide have? So, nucleons is top value, protons is bottom value. Difference between nucleon and proton give us nucleon. So for each we calculate and we find that this is line B. Last question. A neutron is composed of one up quark and two down quarks. When the neutron decays to a proton, there is beta emission. What is the change in the quark structure of the neutron due to the beta emission? Here can be different approaches. First of all, neutron should change into proton. It means that we need beta minus electron. Even if you don't know this, so we should choose either A or B. Even if you don't know this, you know the charges. For example, charge is conserved here. Here charge is conserved. Why? Because minus third E equals plus third E plus minus 1. Plus minus 1, which is electron. The same for next line. But lepton number here is not conserved because electron is beta particle minus is electron. It is lepton plus 1 number, electron number plus 1. Here should be antiparticle because before we don't have lepton. So lepton number was 0, it should stay 0. So we should choose B. In C and D charge is not conserved, and so answer is B. Paper is over. Thank you for your attention.